We now determine the rectangular form and exponential form of this power of this complex number. That is, we are given this complex number in power form, which is root 3 times of cosine of pi by 6 plus I sine pi by 6, and this is raised to the power of 8. First, I'm going to consider this inside expression, which is the complex number, as z. That is, let z equals root 3 times cosine of pi by 6 plus I sine pi by 6. And so therefore this expression is equivalent to z raised to the power of 8. So basically we have to determine z raised to the power of 8. And for that we can use the de Moivre's theorem, that is, and this states that if z is a complex number which is written in the form of z equals r times of cosine theta plus I sine theta, then z raised to the power of n, that is nth power of z equals r times of cosine theta plus I sine theta, and this is raised to the power of n, and this equals r power n times of cosine of n theta plus I sine n theta. So this expression is basically the expansion of the de Moivre's theorem, which says that if z equals r times of cosine theta plus I sine theta is a complex number, then z power n equals r power n times of cosine n theta plus I sine n theta. So using this, we are going to find the z power 8. So let's do that. I'm going to copy the z. So we have z equals root 3 times of cosine of pi over 6 plus I sine pi over 6. Now we find z power 8, which is the thing that we have to find. So we have to exponent both sides with respect to the power of 8. So I write down this as cosine of pi by, I'm sorry, this is pi over 6 plus I sine pi over 6, and we raise this to the power of 8, and this equals when we apply the de Moivre's theorem here, n equal to 8. So therefore this will become also, this is r, that is r equals square root of 3. So according to the de Moivre's theorem, we have to raise r to the power of n, that is r equal to root 3. So it becomes root 3 raised to the power of n equal to 8. So it becomes root 3 raised to the power of 8. And then cosine of, if it is a theta, when we use the de Moivre's theorem, it becomes n times of theta. So here we see that theta is pi by 6. So n times of, that is, it becomes 8 times of pi over 6 plus I sine. Basically, we get the same expression, that is 8 times of pi over 6. So we have applied the de Moivre's theorem and got this expression. Let's simplify this. Root 3 can be written as 3 raised to the power of 1 half, and this is once again raised to the power of 8. Now we can simplify this inside expression, that is 8 times of pi over 6. We cancel this as 4 times of 2, and this is 3 times of 2. So it's basically 4 pi over 3. So I'm going to replace 8 pi over 6 as 4 pi over 3, and we have to put the same expression for the sine term as well, that is I sine 4 pi over 3. Now let's simplify this. This is 3 raised to the power of 1 by 2. So these two powers will get multiplied. That is 1 by 2 times of 8. And this equals 4. So therefore this becomes 3 raised to the power of 4. And then multiplied with cosine of, I'm going to write down this 4 pi over 3 as sum of reference angle. This can be written as pi plus pi by 3. And this pi by 3 is the reference angle. So I put this as pi plus pi by 3 plus I sine. And this also pi plus pi by 3. So in the next step, this 3 power 4 is 3 multiplied with itself 4 times. So it is 81. And then this times of, now we can use this quadrant information to calculate this expression as well as this expression. So let me draw this quadrant thing. And this is first quadrant, every ratio is positive, and in second quadrant sine and its reciprocal are positive, and in the third quadrant, that is cosine, is positive. Since pi plus pi by 3, this basically lies in quadrant 3. So this is pi, and this will be pi plus pi by 3. So since it is a cosine of pi plus pi by 3, cosine will be, I'm sorry, the third quadrant is only tangent is positive, not the cosine. So I put tangent here. And this pi plus pi by 3 lies in third quadrant where only tangent is positive. So I can write down this as negative of cosine of the reference angle, which is pi over 3, and then plus I times. Once again, this pi plus pi by 3 lies in quadrant where tangent is only positive. So sine is also negative. So I can write down this as negative sine of the reference angle, which is pi over 3. So let's simplify this. So this equals 81 times cosine of pi over 3 is basically half. So this becomes negative half, plus we have a negative here, so I can put this as a negative I. Sine of pi over 3 is root 3 over 2. Now let's distribute this 81 into the two terms inside the brackets. So that therefore this becomes 81 times of negative of is negative 81 over 2, and then we have negative 81 times of root 3 over 2, which is 81 root 3 over 2i. And so this is the rectangular form of the complex number expression, where the first term, which is the real part, is x, that is x equals negative 81 over 2, and then the imaginary part y equals negative 81 root 3 over 2. And now to write the exponential form of this complex number, we go back to the step where we have expanded using the De Moivre's theorem. That is, in from this step, we can determine its exponential form. So let me copy that over here. So we have z power 8, and this equals, we had 3 raised to the power of 1 by 2 raised to the power of 8 times of cosine of 4 pi over 3 plus I sine 4 pi over 3. So this, when we simplify, we get 3 power 4. These two gets multiplied and we get 3 power 4. So basically we get 81 times of cosine of 4 pi over 3 plus I sine 4 pi over 3. We identify r and theta from this expression. So this number which comes in front of this complex number expression basically represents r, and the argument part of sine as well as the cosine function basically represents theta. So therefore, this complex number expression is written in terms of r e power I theta, and this equals replace r by 81, so it becomes 81 e raised to the power of I times of replace theta by 4 pi over 3. So this is the exact complex number expression or the exponential form of the complex number expression, which is z power 8. And this is a rectangular form which we have already determined.